What determines if a substance is a solid, liquid, or gas? In our previous video, we talked about solids, liquids, and gases, but what makes a solid, liquid, and gas? It depends on the temperature and pressure. Each substance has a different temperature and pressure where it undergoes these changes, and that can be seen in a phase diagram. So this is a phase diagram. You'll need to be able to read the phase diagram, understand what's going on, being given points, look at the temperature, which is going to be on the x-axis, and pressure, which is on the y-axis, to see what changes occur. So the first thing that you should label on your phase diagram is where solid, liquid, and gas are. Solid is always at the low temperature and high pressure. Gas is always the highest temperature and lowest pressure, and liquid's always in the middle of the two. Then, the next thing that you should recognize on the phase diagram is the solid line between two phases is where you have both phases in equilibrium. So anywhere in this section I have just a solid, anywhere in this section I have just a liquid, and everywhere on this line I have solid and liquid. Why I have solid and liquid is because if I'm going from point A over, I'm starting as a solid and I'm going to a liquid, which means at point A, melting is occurring. So it's basically solid, 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 solid. Right here it's going to start to melt, so I have solid and liquid until it finishes melting. Once it's completely done melting, then it's going to be a liquid that's going to start heating up. Think about when you pull an ice cube out from the freezer and you put it on a table. It's going to start warming up and then it starts to melt. You're going to have a mixture of solid and liquid until it's completely melted. And then if you come back later in the day, it's going to be the same temperature as the room because it heats up to that amount. B is the opposite. It's starting as a liquid and it's going to the left to become a solid, so that's freezing. C, you're starting here, which is a gas, and you're going to a liquid. So gas to liquid, which is condensation. D, you're starting as a liquid and you're going to a gas, which we talked about was vaporization. So everywhere on this line, we have solid and gas. So E, I'm starting as a gas, and I'm going to a solid. Remember, gas to solid was depositation or deposition. I like to think of it as depositation because it's like a solid is depositing out of thin air. F, you're starting as a solid and going to a gas, which was sublimation. One point that we haven't talked about is this one in the middle. So here we have solid and liquid. Here we had liquid and gas, solid and gas. So in the middle, we have the triple point. The triple point is where the solid, liquid, and gas all coexist. Another type of question that you could see is they give you this dot, this maroon dot, and say, if you increase the pressure, what would happen to the maroon dot or the substance if that was its temperature and pressure? So if I increase the pressure, and I was right here, increasing the pressure, it would go up to the point where it would turn into a liquid. The particles would start getting closer and closer until they liquefied. Or if it said I was here and I decreased the temperature. Well, if I start decreasing the temperature and keeping pressure the same, it would still liquefy because the molecules are moving slower, allowing them to form attractions and liquefy. Or maybe you're given this pink dot and asked, how could the pink dot undergo sublimation? Well, sublimation is going from a solid to a gas directly without going through the liquid phase. So I could increase the temperature a little bit, but really the only thing I would want to do is lower the pressure. If I lower the pressure enough, it's going to go from the solid phase to the gaseous phase without passing through liquid. So that would be sublimation. Or if I had the pink dot and I started increasing the temperature, first it would liquefy and then eventually it would vaporize. The last thing you need to recognize on the phase diagram is on your diagram we have 1 atm. 1 atm is what we refer to as standard pressure. At standard pressure, if we follow that over, we get to point A. Point A is between solid and liquid. So at point A, we have melting occurring, but because it's at standard pressure, we refer to circle A as the normal melting point. Everywhere on this line, melting's occurring. So it's a melting point everywhere on that line. What makes it the normal melting point is that we're at standard pressure. If you continue over to point B is between liquid and gas, so that's where vaporization occurs. And it's at standard pressure, so that's what we refer to as the normal boiling point. If we lowered the pressure, it would boil at a lower temperature. So here's point B at standard pressure. If we lower the pressure, notice now it can start boiling at whatever this temperature is compared to this temperature. Notice when I lower the pressure, the boiling point decreases. That's why when you look on cooking packages, they say when you're at a high altitude, you have to change the cooking because the water will boil at a lower temperature the higher the elevation you have. So at circle A, it says draw what the container would look like at circle A. First, think what state of matter or states of matter are present at circle A. And then if you had 10 particles, I just picked 10 particles, go ahead and draw what it would look like if you had 10 particles. Go ahead and pause the video and make a guess of what you think that would look like. Restart when you're done. So the first thing you should have said is at circle A you have a solid and a liquid because it's undergoing melting. So you should have said that you'd have some in the solid and some in the liquid phase. It doesn't tell us when in the melting phase it's at. Maybe it's almost done melting. Maybe it just started melting. So I need 10 particles and I need some of them to be in the solid phase. I'm going to have 6 in the solid phase. I'm going to have some in the liquid phase. So my liquid are a little bit further apart. My solid is more rigid. So that's what mine looks like. Again, yours doesn't have to look exactly like that, but you should have some in the solid and some in the liquid. For circle B, go ahead and pause the video, figure out what phases should be present in the container, and we'll go with 10 particles in this one as well. So in circle B, it was at the normal boiling point, so I should have liquid and gas. It's on the equilibrium line. Again, it doesn't matter how many you have in each phase. I'm going to have my 4 liquid on the bottom, and this time I'm going to have 6 gas. Again, as long as you have some gas and some liquid, because it's in equilibrium right now, some of the liquid is turning into a gas, and technically some of the gas is turning into a liquid. Same thing here, some of my solid is turning into a liquid, some of my liquid may be turning into a solid.